Okay guys, so here is the answer key to the practice test for chapter 12. This first one, because it's a cube, 2 units on each side, I just went up 2, over 2, and over 2 that way, and then drew in that cube on that dot paper. For this next one, this would be a rectangle. I did see some people writing square. We're not quite sure if that's exactly a square, so just keep that as a rectangle. And then this last one is a triangle, and you can kind of see that drawn in there, taking that corner piece out of that prism. For the next one, it says find the surface area of each of these. I'm going to move this. This is a prism, so surface area equals 2 times area of the base plus perimeter of the base times the height of the prism. The height of the prism is the distance between the bases, so that's 5. Where am I going to write this? I'll write it over here. The perimeter of the base is that triangle. So I'm just going to add up 18 and 6, 24. Perimeter of the base is 24. And the area of the base is the area of this triangle. So the triangle is half 8 times 6. So that gives you 24. So 2 times 24 is 48, plus, multiplying the rest of that out, 168, and that's square inches. For number 5, you have some leeway with how you want to do this prism. Same formula as before. I would probably say the base is this rectangle on the bottom, but you could choose a different base. So the area of the base is 96, 2 times 96, plus perimeter of the base, these add up to be 20, so the perimeter of the base is 40, times the height of the prism. So I'm just going to multiply that together quick. 432, and this is square meters. So obviously this is just meant to be something fairly quick for these. If you do need to pause it, or if I'm going too fast, if you're trying to do multiple problems, feel free to pause it. This next one, surface area of a cylinder, is 2 times the area of the base, so 2 pi r squared, plus perimeter of the base times the height of the prism. The radius here is 6, and the height is 10. So I'm just taking those numbers and plugging them in, and then going to multiply that on my calculator. .2, and that's square inches. This next one, same formula. So this is going to be 2 pi times 2 squared plus 2 pi times 2 times 2. Sometimes what I do when I type this in is I type in multiple things at a time, so I will try not to do that, but sometimes I can't just help doing like the 2 by 2 on my own. Let's see, 50.3. And that's square meters. Okay, I had already done number 8, so I'll just kind of talk through that. The surface area is area of the base plus half the perimeter times the slant height. They give us the slant height here. If they didn't, it would be drawn into like that middle point. The area of the base is the area of the square, so that's 4 by 4, which is 16. Perimeter of the base is 4 times 4 again. It's just a coincidence that those are the same. So 72 square centimeters. For this next one, they don't give us the slant height or the area of the base. I can find perimeter of the base to be 50, because all of those would be 50. I'm going to have to find, I'm going to draw the apothem this way and draw in like that central angle. So that's going to make this part 5. I want to find the apothem. This central angle is going to be 360. You can divide it by 5 and then divide by 2 again, or just divide by 10, is 36 degrees. So tangent of 36 equals the opposite over adjacent. So I'm going to take 5 divided by the tangent of 36. The apothem is 6.8819. When I'm finding the area of the base, it's half the apothem times the perimeter. So that's going to be half of the 6.8 number times the perimeter, which was 50. So the area of the base is 172.0477. And then the formula for surface area of this pyramid is the area of the base plus half the perimeter of the base times the slant height. I still need to find the slant height. I'm going to draw it in here. The apothem, remember, was that 6.88 number. I'm going to use that with the 9 and use that in the Pythagorean theorem. So 9 squared plus 6.8819 squared. Taking the square root of that. The slant height is 11.3296. So the area of the base the perimeter of the base times the slant height surface area is 455.3 and that's square meters. So feel free to pause it there if you need, or go back and rewind. This next one, surface area, is the area of the base. And there's the rest of it. They give us the radius, they give us the slant height. So I'm just plugging those numbers in. So 25 pi plus pi times 5 times 14, 298.5. And that's square meters. And this last one here, again, they give us the height, they give us the slant height. If they wanted to give you the actual height, they'd have like a little line drawn in there. So these are both the numbers you need. So pi times the radius squared plus pi times the radius times the slant height. Just going to go in and multiply that stuff together. 728.8, and that's square inches. The next one, the directions change to volume. Volume of this is the area of the base times the height. Again, you could pick the base to be something else, but I'm going to say that one. Basically, for a rectangular prism, you're just multiplying all those numbers together. 2,304, and that's cubic centimeters. Number 13, it is important that you pick the correct base. For this one here, I'm going to have to use the Pythagorean theorem first to find that missing side. This missing side is 30. And then I can use the formula. So the area of the base is the area of this triangle, half of 30 times 16. So 240. So volume is 240 times the height of the prism. So that's the distance between the bases. 5,280, and that's cubic inches. Are you all done, Kyler? Any questions on anything? Feel good about it? You got my calculator? Yeah. Thank you. For this next one, the volume is the area of the base, which is pi r squared, times the height of the prism. They don't give you the height of the prism, but you could use Pythagorean theorem, or maybe you recognize this is a 6, 8, 10 right triangle. Also, they don't give you the radius. The radius would be 3. So pi times 3 squared times 8. So pi times 9 times 8 is 226.2, and that's cubic yards. This next one has the same formula, even though it's kind of shifted to the side. It's still volume is the area of the base times the height. So pi times 3 squared, the height is 5. So almost the same formula. I'm just going to change this to a 5. 141.4, and that's cubic inches. These next two are pyramids. For those pyramids, you're going to have 1/3 the area of the base times the height. So this is going to be 1/3 the area of this square, which is 15 squared, times the height, which is 16. So I think the way I type this into my calculator is like this, and then just dividing by 3. 1,200 cubic inches. This is a right triangle base. This is another 6, 8, 10. This is the hypotenuse. You could do Pythagorean theorem to find that. So the area of the base is half. 6 times 8. So the area of the base is 24. This is 1/3 the area of the base times the height of the prism. So when I multiply those together, take 1/3 of it, I get 120, and that's cubic feet. Here we go. For number 18, volume is 1/3 the area of the base times the height. They give me the height as 18, but they don't give me the area of the base. If I draw in that right triangle for that apothem, this part is 3. Do you guys need something? Okay. Are you doing okay? I know. I'm hot too. That is. Jason, do you need anything though? Okay. 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 And the answer key is on my website. So let's see. Let's find that apothem. This would be 30 degrees. This is 30 times the square root of 3. Or I know some of you guys would rather have it as a decimal. It's about 5.1962. And then what you can do is use that. So the area of the base is half the apothem, which is that 3 radical 3, or the 5.2 number if you prefer, times the perimeter of the base, which is going to be 36. So the area of the base is this 93 number. 1/3 the area of the base times the height of the prism. 561.2, and that's cubic feet. This next one is 1/3 the area of the base, pi r squared, times the height. They give you the numbers you need here. Enjoy ones like this when you have them. So pi times 64 times 10, 1/3 of that is 670.2, and that's cubic feet. This next one, they give you the numbers except the radius is 10, and they give you the slant height. So you need to find this regular height here. So using Pythagorean theorem, this is 24. So 1/3 pi times the radius squared times the height. So 2,513.3, and that's cubic feet. 21, because this is a 45, 45, 90, these are going to be the same. You could use sine if you want to, Otherwise, if you remember, you can always divide the hypotenuse by the square root of 2. If you divide that by the square root of 2, this is going to be 8 radical 2. Or again, you could do this with sine. If you multiply 16 times the sine of 45, you get the same thing as 8 times the square root of 2. So this would be 11.3137. I'd even show you. There it is. So that is the diameter, the radius. The reason I like to do this in exact form is because then the radius is 4 times the square root of 2. Thank you. And the height of the prism is 8 times the square root of 2. Height of the cone, not prism. So volume equals 1/3 the area of the base times the height of the cone. So 1/3 pi times the radius, which is 4 radical 2 squared. If you're going to do the radical on your calculator, make sure you maybe start with that or push equals in between it. Or do some parentheses. 4 times the square root of 2 squared times 8 times the square root of 2. Make sure you close the parenthesis. Times pi divided by 3. And let's see, the units were centimeters, so centimeters cubed. I'd already done this one, but I'll talk through it. Surface area is not just half the sphere, but it's half the sphere plus that circle on the end. So this is not on your formula sheet. You can remember that's 3 pi r squared, or you can always do half and then add that circle in. For volume, you just find the volume of that and divide it by 2. For this next one, the radius is 3.5, and then you can find surface area is 4 pi times 3.5 squared. So 4 pi times 3.5 squared is 153.9 square inches. Volume is 4/3 pi times the radius cubed. So I always like to start with the cube stuff for some reason. The volume is 179.6, and that's cubic inches. This next one wants me to find the surface area and volume of the sphere. Gives me the circumference of a great circle is 10 pi. If the circumference is 10 pi, circumference is pi times diameter. That makes the diameter 10, or the radius 5. So the circumference would be 4 pi times 5 squared, which is the same as 100 pi, or 314.2 square centimeters. The volume is 4/3 pi times the radius cubed. So that would be 523.6 centimeters cubed. And then this last one, it gives me the area of the great circle. Area is pi r squared. So if you plug in the 4 pi here, the pi's cancel out, the radius would be 2. Okay. So if the radius is 2, surface area with a radius of 2, remember this is a hemisphere, would be 4 times pi times the radius squared. So let's see, that's 4 pi times 4. That would be the whole sphere. I have to divide that by 2. And then add in the area of the circle again. So plus pi times 2 squared. Or you could really just add that 4 pi back in. So this would be 37.7 square feet. volume is 4/3 pi times the radius square cubed, and then I have to take half of that. Don't forget to divide that by 2. 16.8, and that's cubic feet. This next one says, name 2 lines containing point Z. So remember, lines are great circles. So point Z is right here. I could name this great circle. If I wanted to name that one, that might be like line WT. Or maybe this great circle over here. Remember, you just have to pick 2 points on that line. So I might name that like ZY. There's other correct ways to name that line. A segment containing point R, let's just go RU. That arc, it would be a segment. And then a triangle, lots of different triangles. Basically, let's just pick these 3 points here. So triangle WZV. This next one, it says determine whether this figure, this point is, or this, I don't know, stitching is a line. So because this is not a great circle, I'm going to say no. I had already done these, so I'll talk through them quick. This first one, they are similar. If you match up those sides, you're going to find that those all have a scale factor of 1 to 3. So that makes them similar. For this next one, if you put the corresponding parts together, those also have that same scale factor of 3 to 4. Number 30, it gives you the scale factor is 4 to 7, and it wants to know what the ratio of the volumes is. So I'm going to cube each part to get 64 to 343. For 31, it gives you the ratio of the surface areas to be 40 pi to 90 pi. When I simplify that, I get 4 to 9. And then to find the ratio of the heights, you can take the square root of each. Because this is the ratio of the surface areas, you need to take the square root to go back to the ratio of the heights. On the back page, looks like these things got a little out of order. Whoops, I did the back page first.